Mm. Okay.
All right, Jose. Yeah.
Uh-huh. All right.
So, welcome to Python Bootcamp 2023. I'm Marceline and Gals. I'll be walking you guys through the session.
Now you get feedback. Good way to test the microphone.
Yep, there you go. Maybe we'll use it. Good.
So we're the Research Computing Center. And I think I'm echoing. But you'll also see in the room TY in the back and Casey, who's second grade in. And they'll also be helping with moderation and if you guys have any questions. To do a brief overview of the sessions. Session 1 will be set up in Python fundamentals and loops, and that'll be from 9:30 to 10:30, and that's what I'll be covering. Paul and Jose will be covering session 2, and that'll be at 10:45. Of if all statements and creating functions. Session 3 is at 1:30 and 2:45 after a lunch break, and lunch is on your own. And then that'll be covered by Alex. And session 4 will be covered by all of us at 3 to 4. So there'll be 15-minute breaks in between session 1, session 2, and then between session 3 and session 4, and then there'll be a longer, I think, hour break between hour and a half break between session 2 and session 4. And then for those joining our live stream a little bit late, we just wanted to let you know that due to time constraints, we're not able to provide any live assistance, but for those of you in the room, we'll be happy to help with questions or clarifications. So if you are online, feel free to assist each other in the chat. You also have the Jupyter notebook set up in on your personal computers and open to the session 1 notebook. Each notebook is going to be in each of the for session 3. I believe there's 2 notebooks, so we'll let you know which one to click for that one. And then for session 4, there shouldn't be a folder for that since we'll be doing it through PowerPoint. So I guess I did mention I was covering session 1, but an additional session 0, if you've never seen the Jupyter notebook layout, this is it. So what is a Jupyter notebook? It's essentially that combines both code output and text setup like this. So you can have bullet points, you can have and that's not something that's very common with code. When you have code and like just a notepad and stuff, you have to do comments in a specific way or else the computer will read the comments and the like descriptions that you make. Yes, you can have specific sections that are just dedicated to paragraphs of explanation, and then inline visualizations, and that kind of stuff. This makes your work more transparent because then you can like put in blocks of explanation in between your code, but then it all runs as a single. As you guys can see, this is an IPYNB. That's equivalent to 1 notebook. So you can have multiple notebooks in any given directory. To that main page that you had all of your different sections on, a way to create new Python notebooks is to go up here to new, and then click on Python 3. in a, like your regular account, it should create a new notebook. So to go back, the two different things that are going to be in your notebook interface are kernels, which is are essentially what will run the code. You can have multiple different kernels depending on your setup, but for now, to keep it simple, it's in Python. And the other type of cell is a markdown cell, which is the one that you can have paragraphs and have different markdown formatting. So for example, if you were to click into this, this looks like this when you type everything out. And when you run this, it'll look all formatted as we do. So for, I guess for an example, when you're opening and closing a type of cell, you can click on the cell that you want it to come after, and then it'll have this blue line on the side. You can click this plus button here on the top row, and it'll insert a cell below. So when you do that, when you do the automatic plus, it creates a code cell, which you can see in the brackets on the left-hand side. And so this will run code. You can change it to a markdown cell, which is the one that you can put paragraphs in, by going up to this top bar where it says code, dropping down to a markdown. And as you can see, the code itself gets removed, or the in prefix here gets removed, and now it's just blank. So I can type in hello world, and I run it, it will just turn into normal text. To edit the square, you double click, or change this back to a code block, and you try and run it, it will give you an error. And so you have two different ways of running code, or running each cell. You can click this run button up here, and that's your error. Or you can click Control Enter or Shift Enter. Yeah. So to talk specifically more about code cells in detail, this is an example of a simple print statement, where so if you were to run it, it'll print hello world on the bottom. So when you run a code, it'll have a number next to the line. And that changes basically in whatever order you run that code. So if you were to click run again, that number changes to then 4, which means that it's the 4th line of code or the 4th section of code that's been run in the entire notebook. So as you can see here, this was the second one. And now we run this for the 4th time. And essentially this is to keep track of the order that your code is running in within the notebook, because you can run things out of order. So for example, if I wanted to run this line again with the error, it'll show as 5. I guess getting a little bit in the weeds here, this in here is for input, and so it's the number line that has gotten input within the code. For these, as you can tell before, when I ran hello world, it gave me an error unless I had the print statement. When I run this, it doesn't give me any errors. Pound or hashtag set that follows and precedes the line. And that's effectively how we do comments in code. These are, again, for human readability. The computer's not reading these. And this is to make sure that you know what you're running and what your code is doing, because if you come back after an hour, you may remember what you were doing with your code, but if you come back after weeks or after months, then you're like, what is X? What are all these variables that I've inputted? And this is also helpful if other people are looking at your code as well, to be like, this variable stands for this number, and these are the calculations that I've done. I mentioned in this block, note the 1 to the left, and as you can see, there is no 1 to the left. I have toggle line numbers. I have them specifically say the line numbers on the side. And that's so that I know when an error occurs, it will tell me there's an error occurring on the specific line, and then I can go back and see which line they're talking about within a specific block. And that is under view and toggle line numbers, so that can come in and out depending on whether or not you want that. So this is really helpful for error. Again, it's view and then toggle line numbers. So I'll turn that off for now until we get maybe closer to when we talk about errors. So for the first exercise, maybe if you're going ahead a little bit, you have seen this exercise already. Below the cell, insert a markdown cell and then write down one thing you hope to get out of a Python bootcamp, because we do cover a lot of different information, or like what you're most excited to learn, because as we are going through Python bootcamp, the hope is that we learn Python, but anything specific that you're interested in, and also just to practice working in the Python notebook. And no worries, no one is asking you to share and raise your hand for this, so anything that you want to put in is part of your own journey for Python bootcamp.
Hey.
Oh, yeah.
What?
Saw that the other day, and I was like, oh my God, because they outlined that the first two, and the case they had like in the store, and then they. Right, and then I went to hear that, like, so weird, so it was like, here. I might pull it.
So I've just been informed that like not all the notebooks are writable. So if you aren't able to edit your notebooks, just let us know. And
We're working on fixing it.
we're working on fixing that. So if you, I can skip over that, come back to it later. If anyone has any questions so far, let me know. Because this is a good stopping point before we jump into session 1 of the session.
There was a big little I still don't have a lot. They don't seem to have it. She was before.
Yeah.
I would use some stuff. Okay, so back here.
and variables. Does slightly touch on how to use a function, but we'll get more into the weeds for that for session 2. And talking about creating a function. And then these are all the key points for going into the variables and mini functions and just fundamentals in general for Python. First off, Python can be used as a basic calculator, and as you can see, there's an example of code. So they don't necessarily have to be relevant to the code, but it is helpful if you associate it with code that makes sense, or even if you're passing on to someone who doesn't know code as well, you can just be like input number here, that kind of stuff. So if you run this code, it'll give you 3 times 5 times 4, which is 23. But in the same way that you're using a calculator and you're adding different numbers to it, you just kind of take the previous answer and run with it. There is no real way to do that for this if you aren't giving variables. So variables are essentially a way to save a value to a specific name. And then it'll also give you that helpful description of like, what is this number? You assign variables to values with equal sign. The variable goes on the left and the value goes on the right. So for example, if we were to do 60 equals weight, it will give you an error because 60, it's assuming 60 is the variable and that weight is the value that you want to assign it to. So similar to passwords, variable names can include letters, digits, and underscores only case sensitive. So the 2 different examples that I give, or I guess non-examples, one is 0 weight. So if it starts with a digit, then it'll give you an error. If we will take out the 0 and then run it again, then it's fine. Another thing that's super helpful is when you're running code, if you know the expected output, you can list it above. So that way, you know that you're getting either the right output or the expected output when you actually run the code. Okay. Yeah, so later on I talk about when they are when they essentially read the same, but one is capital, one is not, they're reported as different variables. So there are 3 common types of data. There are whole numbers, decimals, and words or phrases. You'll hear them more commonly stated as integers, floating point numbers, and strings. And as we go through this, you'll see that all of these should not return an error. Strings, so numbers, whole numbers, and decimal numbers can just be on their own, just the number itself on the right-hand side of the equals. However, for strings, you have to format it within either single quotations or double quotations. So they can be a number, a phrase, or a mix of numbers and letters, including all the symbols that you want. And as long as they're surrounded by single quotations or double quotations, then it'll be fine and not error out. So, and this is what I mentioned before, if you have different variables, one with capital, one without, and they could be anywhere. So I want to capitalize the T at the end. and add those. We have this lowercase, all lowercase weight here, and this should give 70 because of what we ran before here. When I change this output, and this is also something that's a little confusing about Jupyter Notebooks, is that you can change the output, but it'll still remember. You can change the code in the block, but whatever you have actually run is what it'll remember. So if we're going to run capital W, the uppercase weight is 0. This line over here. Jumping into using variables in Python. So it is helpful to have a sticky note for a value, but what if you want to change that value? Well, it's the same way that we assign variables now, by putting the variable name on the left-hand side and then the number that we want it to be on the right-hand side. We can make those calculations on the right-hand side. So for example, let's add a block here to print what these values are right now. So weight, kilogram. If we run this, it's 60.3. We can add another block to say print weight pounds. And so that is not defined right now. But if we set it to be equal to this calculation, 2.2 times weight kilogram, this should run fine. And then we go back to the print statement, it'll give you a value. Yes. So, a little bit into strings. We can have strings on their own, but if you want to add more to the string, plus sign next to the variable that currently exists. So we ran patient ID earlier, and we can just check that patient ID value again with that print statement. Patient ID, and then run. That's 001. And this right here is changing patient ID to have inflame in front of it with an underscore, plus the patient ID. So if we were to run this, it runs, and when you go back to print patient ID, it's inflame underscore 001. So when you're adding strings, make sure that the string itself is in single quotations, either before or after the string variable that you want to add it to. So, if it does not exist yet, then it will become whatever you assign it to. So if you assign it to a string, then it will become a string, but you can't add a number. So, you know what, let's see. So patient ID. Number to a string. So it gives an error. You can't add a number to a string. So patient ID will remain a string. Add a number to it, and this is a number without quotation marks, so it doesn't consider it a string, it considers it a number. And yeah, before I move on, are there any questions about this? I am going relatively fast with variables.
That's dumb. So for the like print command, that just means like because I think before we like that just means to like print it.
Yeah.
Okay.
We'll get into that in the next section.
Okay, sweet. I'm jumping ahead. Sorry then.
Yes. Yes. Are there any questions about variables so far, or at least like the intro to variables. Can be formulated into questions. We can also pop concepts in there, and then we can talk about those. Let's see, none. We'll move on to built-in Python functions, which is print. So basically what it is that so functions in general are mini code instructions that we can call by just calling the function name. You can typically see functions name following two parentheses, and then sometimes there's information inside of the parentheses. From our example, print is one of those built-in functions for Python. Some functions are built into Python where you don't need to import anything extra. Other ones you have to import specific libraries to then say like, oh, I'd like to use this function from this library. But Python has some built in, just like print. So with print and other functions, sometimes we'll know the output, and other times you can look it up. There's actually a Python library that'll tell you like, oh, this is a function, it's in this library, this is the input it requires, and this is the output that it'll produce. Sometimes it doesn't produce an output, and then sometimes to see if it works, it does produce an output. Let's see. So for print, we have been using it very liberally now. From our explorations with print, we know that print can print out the variable or the value of the variable given the variable name. And then here I went a little bit crazy, and you can print actually print the string and then the value of the also I guess like minute detail. This says lowercase weight equals without a space in between, and this comma will then act as a space to then print the weight next to it, the weight value. That's something to keep in mind. So if you decide to include the space and then run this, they'll add another space. So there'll be two spaces in it. So what print does is it takes in these values and then returns it to the screen. As much as sometimes this is helpful to us when we are trying to figure out what the value of the variable is, what value is that variable holding. When we go through and we're debugging and hoping for a correct value, and seeing where in our code the values are changing when we don't want them to. We can also sandwich strings in between variables in whatever order that you want to do it in. So for this example, patient ID is the first variable, and then the last variable is weight in kilograms, and then we have weight in kilograms as a string in between. And when we print that out, we'll have the patient ID, weight in kilograms, and the value of the weight in kilograms. Yeah, so we can combine the things that we print with commas and single quotes. So if we were to even remove this string in the middle and just leave one comma, then both of the okay. So another introduction, a very brief introduction to another built-in Python function is type. So we talked about the types of data that Python will hold in terms of variables, such as integers, floating points, and strings. But if you want to check to make sure that you're not adding numbers to strings and you just want to check what type is the variable, there's actually a function for that called type. So when you just use type without the print statement, it doesn't print anything. It doesn't return anything to the screen. So print automatically returns things to the screen so you can see what the given output. And this, so if you print the type of this floating point number, so a decimal, it will produce class float. So patient ID over here is a string, and it prints out str to represent string. If we were to change this to 60 and run that, it produces int for integer. And those are the three common types of data. Okay, so another thing you can do is you can put calculations into, which we already know that we can put calculations into new variables, but we can also make sure that the output itself in print is that new value that we want based on an old value that we have. So for example, weight is this string variable and or this string value. And if you multiply 2 times 2, 2.2 times the weight in kilograms, you get the weight in pounds. And so that changes the value to 132.66. But if you go back and you print the weight in kilograms, it will still be 60.3 because we haven't reassigned this weight in kilograms value to anything. Change the value so that it appears differently in the output. But if we value itself, so if we change weight in kilograms to equal 65 now, and then we print the weight in kilograms now, it changes to 65. And even if we go up here, it will now be 65 instead of 60.3. As long as you use an equal sign and set the variable name, you can change the values. Just know that if you already have it set somewhere in your code, you may run into issues if you try and reassign it to. So, for example, if we try to reassign weight in kilograms to a string, so it completely changes it. But if we are to, but if we try and add a string to it, then it gives you an error. So you can't combine, data types, but what Python will let you do, and this is not common through all coding languages, but Python specifically, is that if you set it to a new value without modifying like the original value, so if we're not changing the type of it by adding on to what's already in the variable, so like if 60 is already in there and we're trying to add a string to it, it will give you an error because you're mixing data types. But if you were to say, instead of weight in kilograms being 60, I want weight in kilograms to be hello world, it will erase it and just put the new, then the string type will change, or the variable type will change. So that is fine. Yeah.
Being the full variable, you don't have to declare the type of data. It's just assumed that whatever value is assigned to that variable.
Yes. Yeah, so whatever the value that you're assigning to the variable, just to restate what you're saying, is attached to that variable and you don't have to declare it outright. Like, for example, in other programming languages, you have to declare outright that the weight in kilograms is always going to be a floating point. So that way from then on, any changes you make to that variable will always be a floating point. But with Python, it does all of this kind of in the background. So I guess use the analogy that variable names are sticky notes. So we just like kind of like pop that on to any value, depending on. So here's a comment that specifically concerns the code that's within this. So there are 2.2 pounds per kilogram. So if we were to try and get the weight in pounds, all we would need to do is multiply 2.2 by the weight in kilograms. And then we can practice print statement, strings, variable strings, and then another variable. Okay, so this because we changed the value of weight in kilograms to hello. So if we go back and we change it to 0, then it should work. Another thing to note is another thing to note is that I put a decimal point after 65.0. So if it is a whole number, it will not have a decimal point. If there's a decimal point, even if it follows with a 0.0, it is a floating point. So that's something to keep in mind. Oh, another thing to keep in mind is when you are, so we know that string, it gives you an error. When you mix an integer and a float, it will give you a float. So it will always give you a decimal, even if you are multiplying in an integer, just because that is more complicated. But when you're multiplying an int and an int, it will give you, when you divide things, it will always give you a float, even if you're dividing integer by integer. So now that we've changed to 5, it should go, yeah. And 143 in pounds. And then, so here's the thing about sticky notes is that you have to make sure that you know where the sticky notes are. So for example, this next line, if we change the value of weight in kilograms to 100, but we don't do anything to weight in pounds, the weight in kilograms will change, the weight in pounds will stay the same because we haven't rerun this code in the first block where we are reassigning weight in pounds. So, so sticky notes, weight in kilograms moved from 65 to 100, and then the weight in pounds stayed at 143. So if we run this again, it is 100 and then 143. So yeah, so before we do some exercises, which you may or may not be able to do because of editing things, what questions do we have about variables and functions? Yes. So, so essentially what it is that whenever we do a variable name and an equal sign, it's essentially whatever that value is on the right hand side to the name on the left hand side. So you're putting a sticky note on that value that it says like, this is that value's name.
Oh, so it's just the same thing as the variable.
Yeah. Oh, okay. Yeah. So it's just like another analogy to make sure that like when you assign things, you just have to remember that they retain whatever value you last put on them. as you go through, which is why it's very important that Jupyter Notebook keeps track of what line you run at what given point, because in Python scripting, usually it runs sequentially, but in Jupyter Notebooks, you can run things out of order, which then means that maybe your variables have changed at one point. For example, the weight in kilograms is hello. You would not be able to run all of the extra code afterwards, like considering it a number, if I were to make the changes and leave it as a string. Okay, what other questions do we have? About variables and functions, built-in functions. So we did go over a lot in a relatively short amount of time. So there's a small exercise that's after this, and we'll have our moderators walking around checking to see if anyone has any issues. But there are 4 lines of code that you can run below in the code block that's empty. And so they're just 2 lines with mass and age, and then a change in value. So let me know if you have any questions. Code block. So if you input the
Yeah.
That's the very
Each of those values.
Oh, it was just space at every comment.
Yes.
But of course, that's pretty cool. Based on that print. Really? Graphical.
Oh, okay.
Yes.
So very much so.
All right, well, doing
I see, okay, okay.
First thing we can do is.
I mean,
The brakes.
I just did it.
The whole run.
Screen is that way.
Yeah, the car is just getting into the format.
You can.
Okay.
Yeah, you can see the. And
With that, I should. So by the two, that they both.
when you do it, so they-
Short for your break. So from the check your understanding, we have 4 different lines of code where mass and age have an initial value, and then we do calculations on. And those 4 lines itself will not give you any output. But if you print the mass and the age, you can see that the values of them have changed. So yes, we can save things as variables, and yes, we can built-in functions. And we can change the variables themselves. But what else can we do in Python? So a element of this is or a fundamental element of Python is using loops, and just a general coding fundamental in general is for loops. So first I'll jump in with showing you a more complicated data type that Python has, and we'll see a little bit more of this later on. Is that as you can see, there's this odds variable, and next to it, next to the equal sign, is a bracket of 4 different values with commas separating them. This is a list. And a list is an collection of elements with an index. So not only does each number have a particular value, but it also keeps track of where that is in the list, which is important. Because then we know exactly how to call it by calling its specific index. So right now, I guess we're going to jump into the weeds, and then we're going to jump right back out. So I did say an ordered collection of elements, which means that not all values in this list have to be the same type. So these, for example, are all integers, but you can have 1 and like Charlie and like 7.5. And so those can all exist in the same list as long as they are separated by commas, and then you have the strings, of course, in either single or double quotations. But for this example, we'll just go really simply. If we wanted to print every element of this list, we can denote it by saying odds, which is the name of the list. Open bracket, as you can see, this starts with odds 0. So in different programming languages, the indexing differs. It can either start with 0 or 1. Python is a 0 indexing language. So the first value is 1, and that's going to be at index 0. So if you want to print all of the values in odds, you can go 0, 1, 2, 3 as your index values. And it will print all of the numbers in odds. We can print odds, the list called odds, by itself. But sometimes you just want, oh no, I lied. Because I haven't defined odds. So once we define odds and we run that line of code, because Python doesn't know what odds is once I tell it, we can print odds, but it will retain the brackets and the commas. And so when we do that, we can't interact with each element separately. So if we were to say, try and do +1, and we want to add that to the first element, it won't let us because we're mixing values again. Okay, so as we do this, so this is not a great model for printing out all the values in odds, because what if odds is 100, like 100 elements long? So that's basically like you would just rather print out and type every single number than print out odds 0 through 99. So if you're trying to make minor changes to each element, you would then have to do it in each separate print statement or each line, which is difficult to maintain. And then since we have how long odds is, so we know that it's 4 elements long. But if we say created odds like way back on line 1 of our Python notebook, and we're like, okay, I just want to print all of the values in odds individually. You're like, I'm pretty sure there are 4 of them. And then you try and do that print statement. It can either error out because there are not 4 elements in odds, or there's more than 4 elements in odds, and then you'll get a partial list. Our problem. So to print out more elements of odds than there are. And then we can do what we had. So they can duplicate. So yeah, so if we only print the first 4 elements of it, then it's a partial list. And we're missing 11 and the second 5. So what we can do, right, and just tell Python, can you print all of the individual elements in the odd list in this for loop? And so this is the typical structure of a for loop. You start with 4, and then what you consider the element value to be, so num, and that doesn't have to be assigned ahead of time. This can just be whatever name you'd like. So since there are numbers in odds, we call the first, or we call that iterator variable num. So for all of the elements in odds, which is a list, we then provide at the end of that first statement with a colon at the end. Then you indent to tell the, yes. Oh, you're just stretching. Okay, never mind. So then you want to tell, after you indent, whatever is all going to be indented to make sure that you know that it's in the for loop and not outside of the for loop. So for example, because it's expecting something to be in the intended block. But if we print odds after odds one time and not every time it goes through the for loop. For this example, print num will just print every element in odds all by itself. And so instead of doing 4 lines of code, we can do 2 lines of code. And then of course, if the list is longer than 4, then we then only have to do 2 lines of code for all of that. And this doesn't matter. It doesn't matter how long odds is, it will still print all of the values. Here is a of what's actually happening in the for loop. If this makes more sense to your brain, it does to mine. That here are all the elements in odds, and num is going through each and every single one of them. And then at each loop, you are printing the num that exists within that that moment in time in the loop. So like I said, I use num that made the most sense for the code. You can use banana. You can use whatever variable names you want. But when you come back in months or years, will you know what banana meant? So make sure that you're commenting your code, which we talked about briefly before, and we'll have a couple different sections talking about that as well. But also make sure that your variable names are something that you understand. Let's see. So there are a couple different examples. So we've done print num, which changes that value changes every single time we go through, and it's not referring to the same value. We can do something called programming languages, where you set a specific value to change over how many times you run through the loop. So as you go, for this one, as you go through the list, the length is increasing by 1. So since there are 3 names in this list, the length will be 3. And then the other aspect of it is this other aspect of it is that once you get out of the loop, whatever your num banana name. So when we run the loop Curie, Darwin, and Turing, after the loop, it's still Turing, even though we are outside of the loop. So that value still exists. It's just not changing because we are outside of the loop. And then there's another, so the length of a list is something that we can do here with the 2 lines for the for loop. But it is also one of Python's built-in functions called length, which is just len. And what you can do is you can put just like the plain list in here, which will give you the value of 4. You can also type in the name of the list. It'll also give you the length. So that's not a 0. And that's the list. So yeah, so that's another thing to check for the length of it. Again, with functions in general, you have to make sure that you have a open parentheses and a closed parentheses at the end of the name of the function, one to denote variable, and then whatever the input that it requires within those. We did this a little bit before when we were printing the type of variables. So you can actually have functions within functions. So this print is a function as well as the type. So as long as you put inside print what you want it to actually print, then it will give you that output. So I am running a little bit out of time. And so before I run out of time and before we go on break for 15 minutes, does anyone have any questions? Yes.
So when you went through the link, you said like LEN and then parentheses. You have to say print in front of that.
So if you don't, I guess let's see. So if you type in lang and then you don't type in print, right? Then won't print anything. You can set this value to a variable and then print that variable as well, but you can also just print the length as long as it's within those parentheses.
Note, add a 1 to every number in your list.
Yeah. But yeah, so I can
We'll
give
cover
it.
that a little bit more in a second.
Okay, there, yeah. But yeah. Again, just the fundamentals for now, before you guys go on break. Does that answer your question? Okay. Any other questions?
The one section that I didn't understand was the one that's in the book, you just scroll past the
Okay.
name equals one. Explain that little section one more time.
Okay, so yeah, so we can set Roslyn, in the beginning, as the name, but if we're using the name as the iterator in the for loop, then it will pull the first element in the list.
Okay.
And this is the list that's set for this for loop. So if you print name, it'll just print that first element and it'll completely skip over this.
Oh.
Yeah.
Okay, got it,
Yeah.
got it.
Yeah, sorry, I did go over that, not at all. So thank you for pointing that out. Yeah, so that'll only print out the 3 and then, so basically it'll be like the Roslyn's equals did not exist at all, at least for the print statements.
Yeah, the iterator the iterator actually will be, it is basically just a variable like
Mhm.
anything else. So every time it goes through the for loop, it changes the value of name until it gets to the end of the loop. And so at the very end, Muslim won't exist, but it will be.
Are there any last questions before we take a break? Okay, seeing none, I'll just put a timer on the board for 15 minutes, but we'll be back at 10:45.
So you want to leave it?
It says you can do that.
Yes.
Okay, hello, everybody. My name is Jose Hernandez. I'll be your presenter for this part of the session. Do you have any questions? Go ahead and raise your hand. And yeah, so in this, can anybody hear me through the thing? Casey, all good? Perfect. Okay, so in this session, we will cover making choices. So we'll cover a bit of how to use if, elif, else statements, and how to correctly evaluate expressions containing and or expressions. So we'll get through those. And that is just the links to where we got this information in the exercises in case you want more information as we go through. Before we start with if, elif, and else, I'm just gonna give you an overview of how to input data into Python. So what makes Python very big functionality tool is that you're able to import what we call libraries. So libraries is like getting a piece of extra equipment and bringing it into your environment, right? So here we're importing 2 libraries. So we're importing NumPy and we're importing Will. Many hundreds of libraries that you can bring into Python, and each one is tailored to their own purpose. And each one has functions that we can call, and we'll learn later on how to do that. In addition to libraries, you can also, Python also accepts many different data formats. One of the most common being CSV, which stands for comma separated data, right? So CSV stores information, just like the title says, with commas in the middle. So for example, 1, 2, 3 separated by commas, apples, oranges, bananas separated by commas, and it's usually a lot of information organized, similar to how Excel organizes the information, right? Rows, columns, pretty standard format. And we'll see how we can load one in. So using the NumPy library that we just loaded, we can tell it from NumPy, the library, load text, the name of the function that we're using, and we call the file name. That's the name of the CSV, and it's important the delimiter, so that breaks the data, right? We need to tell the function where does it break when it's reading it in, right? So the delimiter in this case, the commas as the CSV explains, and it would just load all that information in. Okay, so this is the way we read information into Python. in this particular case. Okay, so that's just quick. In this case, the CSV is just results from a clinical trial on inflammation. And it contains the number of inflammation flares per day for 60 patients. We'll be using that data set as we go through the. So it's important before we keep going, click on that arrow, so it runs that code, right? And it actually pulls the CSV in. If not, the rest of the files will not work. Any questions on how to input data or how to bring a library in? Yes.
Future reference, if you want to import libraries, you have to install them first. And then they will work. So yeah, keep that in mind. Outside of the built-in Python functions, you would need to install these separately.
So yes, so that's that. And then, okay, so let's go into conditions. So a couple things. So this is the symbols of comparison. So very much like your math class before, Python reads all these just like humans do, right? So greater than, less than, equal to. This one's new, so exclamation mark with an equal means does not equal. Greater than or equal to, less than or equal to. I don't know what that is there. But yeah, so those read exactly how we would read them in normal math equations. The other two functions that that we're gonna use is int, which is an integer. So it converts the input that you put in into an integer value. And then the function input allows you to input a value into the output of the code. And we will see how that one works in a minute. But basically it allows you to interact with the output instead of just working with your initial code. Okay, so those are, we'll see later how they work. But yeah, so let's go into if, elif, and else. So these are codes that depend on the initial condition that you put in. So we can ask Python to take different actions depending on if the condition is met by the code. So for example, if we have a number and we say equals the, this is gonna be way easier to explain once I run this action. So when I run it, right, because I gave it an input function, it will tell me enter a number here. I will enter a number. And by default, input functions output a string, right? So if I'm outputting a string, but I want it to be a number, I have to change the string to a number, correct? Everybody good there? So that's why I have this int there. Because once I put the number, it'll say, oh, this is a string. I can't compare it to other numbers. So I need to pass it to a number first. Okay? All good there? Perfect. So I'll put in any number. Let's say I'll put in 55, right? Got there. And it'll say, it'll go now, the number, if it's greater than 100, it will print greater. It won't because it's 55. And else it will print not greater. So print it not greater, and then it printed done. So we know that function is done. Okay. So this print done actually is outside the if and else statements. Right. So if you have an if, it's important that you also have an else, because you need to tell the function what to do if the if condition is not complied with. Right. So we can actually do many different things with else, but this is a very basic example of how we run the loop. Any questions with that one? I know, yes.
So you had to convert to an integer because the number read in the user was
A string.
String.
Yes.
Because that's what if you put nothing there? You just put input like open parentheses, close parentheses.
It will give you a box. Say enter number here.
Would you still have to convert to integer?
Yeah, you would still have to, because every time you put an input, it just inputs it as a string
Okay.
into Python. Good? Any other questions? Okay, so moving. Okay, so also please run these as we go through so you can also see what's happening. Now the second will do the same thing, but it'll just print. If there isn't one, it simply won't do anything if the test is false. The code will just go through. So for example, if I click here and it says enter a number And if the number is smaller than 100, doesn't do anything. Yes, it will just print before conditional, after conditional, that's just to show you that nothing will happen with the if, right? So if there's no else condition, we'll just skip over the if and nothing will actually happen. But if I do the same thing, but I put a number that's greater than 100. It will actually run through the actual code and it will output 101 is greater than 1. Right? And that's where elif comes in. So elif is short for else if, right? So it's the second if. So let's say you want to print out when it's greater than 0, or if it's equal to 0, or if it's lower, correct? Okay, so if it's greater than 0, we'll say it's positive, but if it's equal to 0, it's 0, else negative. That second if statement cannot be an if, because we already ran the initial if. So that second one must be an elif statement. Okay. The actual code go through. If not, it will not register that second. Okay. So in this case, it will just do the same thing and we'll just input a number in there. So running it, enter a number here, let's say 5, it should output 5 is positive, right? And if we put -2, it should just skip the if, give the elif, go to the else. Okay. Any questions there without the elif? Yep.
Why is there 2 equal signs on the?
Okay, so going back to the conditionals up top, the comparison numbers is equal. It's comparing if num is equal to 0. If you just put 1 equal, it will define as a variable.
It's an assignment right here.
Yeah. So we need to make sure that the second equal goes in there. So let's consider this code first and don't try to run it, just try to see it through. So if 4 is greater than 5, print A, elif 4 equals 5, print B, elif 4 is minus than 5, print C, and which one will come out? Yes, C, okay. So, but it's okay, don't be afraid. It's not a trick question. Python is, it's okay, and then, yeah, it should just print C. And then, yeah, so that should be it with conditionals and the if, elif, and else statements. Any question with those 3 and how they work? Cool. Okay, we'll use them to do cool things later on. But now let's go to lesson number 2. So here we're gonna be working with true and false statements. So true and false in Python are very special because they're called Boolean values, right? If you've ever studied formal logic theory, true and false has there's like specific conditions that they satisfy. In this case, Python identifies true as 1, so there's something, and false is 0, nothing is there. And these values can be coupled with the previous functions to also make decisions in Python. So for example, when you say num equals 0, that condition is looking if it's true or false, right? The Python itself is true or false. So for example, we say print 2 equal to 2, then that answer will be either a true or false, which is true, yes. And then 50 divided by 2 is less than 24, then that will print false, right? And that same way, true equals 0 will be false, because 1 always in Python, right? And then false is greater than -1. So if we run those, it should be pretty easy. False and true are always the default values. And that's important because that means we cannot assign a value to true or false. If you try to say true is equal to apples, Python will not, okay? It's not, because that value has to say default for it to be able to do its eval statements and any other true or false condition, okay? So that's just go through them and write the answers. We need to, but I think those are pretty self-explanatory on those. But yeah, so let's look back at this. Let's look back at this code that we have. So it's saying, why do I keep running into the bottom? Here we go. So it's saying if num greater than 0, then it's gonna identify this condition as either true or false and then satisfy. If it's false, it will go to the other, and if that one's false, it will go to the else. If either one of those satisfies a true condition, it will output the value. But I'm not gonna run it because it's the same, exactly the same code we ran 2 or 3 blocks ago. Any questions still then? True, false, fireworks? Perfect. Okay. So let's consider these few statements, and these ones are actually pretty interesting because Python has defaults for almost everything, and if it's true or false. So if a blank statement, if that blank statement is true, then it will empty out and it will print out empty string is true. If it has a word inside, I will print out word is true. But only the true statements will print out. The false ones won't. Okay. So if you actually run that code, not all of these will print out. Only a few of them will. And it's only the ones that actually have stuff in them. So word is true printed out, non-empty list printed out, and one is true printed out. Right? Do we understand why that happened? No? Not at all? Okay. So you look at this one. If this empty string is a default false for Python, because there's nothing in there. There's no content of it. This empty list is a default false for Python, right? And the 0 is always false, right? So because there's no condition to satisfy, those will not be printed out, right? It's saying if that is true, I will print it out. It wasn't. It was false. Okay. So do we understand that one? It's a bit more abstract in that you actually need. But that's to show you that you can do many things with the printer. Okay.
Is it like other languages where everything that's not 0 evaluates to true?
Yeah.
So any string other than an empty string.
Sure. Correct. Yeah. Okay. Yeah. Guys, yeah, I know this was a bit more abstract example. But yeah, this just shows you what the Python is considered. And then I don't okay. So this is just knots. So knots is basically
Let's go back a little bit because
Yeah.
you said if an empty string is value, so it will always be true. Well, actually, no.
no.
It's very unlikely.
Yeah.
But it still is a value. Well, that's true, yeah, if you don't.
the flat would and full. Yeah. So that will always give you the opposite, right? If I say if not the empty string, which we know is false, then it will say true, right? And then so the not will always give you the opposite. If not true, that's just true. I'm just putting a double negative there. I know it's bad English, but it's just fun code. Yeah. Difference between the quotes and brackets. Yes, so brackets denote a list and the quotes denote a string. Yes. Okay. Okay. So okay. Any questions there with the true and the falses and Boolean values? All good there? Okay. And then the last thing we're gonna cover today is the same thing, true or false, but now with ands and ors. And if you've done a little bit of logic in the past, this should seem similar. But basically, the way or and and statements work is by saying if it's true and true, it's true. So both conditions have to be true for it to be true, right? If I say true and false, that will be false because both of them need to be true to satisfy the condition. Okay, so when you first thing, and that backwards. Well, okay. So yeah, so this is the conditions. The picture's in the wrong place, my bad. So this is the and statement. So true and true, true. And the and statement, everything else will be false for the and statement. And then or is the opposite. Or
If you look at a Venn diagram, the middle of the Venn diagram has to be both of them have to be true, for the middle to be true. That analogy also works for or obviously.
But yeah, and then for or it's the same thing, so false, false, false. Because you went or, but then everything else will output true, because you have true at either of the sides. So if it's true in circle 1, but not in circle 2, it will still be true in the different circles. Okay, so that's true or false statements. That's true, and yeah, with the ands and the ors. And now, I promise this looks like a lot, but it's not that much, I promise. Just follow me on this one. Okay, so we're gonna put it all together. And this, I wrote it all for you, so we're just gonna read it to you. So what does this first line do? Anybody? This first line? Same thing we read earlier.
You want to tell everyone how to install NumPy?
No. For that later, what?
I mean, it's easy if you want me to.
Yeah,
put it on
that-
the board.
Yeah, that first line reads in the CSV.
No, you don't have to.
And then and these are just functions for it to read in the actual, for it to read in the information, but they're not critical. The important part is the add, if, and a link, so this. Yeah, so we have, it's saying, if you grab the code and we say if that value is 0, and if the other value is 20, say this is suspicious, okay? If that value is equal to 0, if the sum of the minimums is 0, print the minimum is 0, okay, because the sum was 0. Okay, you don't need to know what is actually done. And then the else, it will just print, it's okay, because it's neither suspicious. That's a 0, right? But for that, both of these need to be false. And if you run it, then it will just check all the math for you, and it won't run because NumPy is not installed. But in theory it works. Okay. So yeah, so let me go to this one, and that'd be the last. No, we still have 10 minutes, but that'd be one of the first exercises. Okay, so in this one, I'm gonna give you like 5 minutes after this to solve it out. So you're gonna have a for loop. That's for file name in file name. And I'm gonna give you 5 file names, okay? There's 2 called implementation, 2 called small, and 1 called a Meister py, which is a Python file. Okay? You want to divide these files into 3 groups. 1, large files, small files, others. Large files is the information. Okay? And I'll say for file name in file name. If something, put it in large. If, put it in small, and else, put it in other. Okay? So you don't need to put any condition for other. We just need to put in condition and other. Okay, so all of those are strings, and the way we can separate them is by using this beautiful function. It's called start with. So I can tell it if the string starts with INF, put it in, and then if it starts with SMA, put it in small. Okay, so if you want to try and see if you can fill out that if statement, what would be the condition there? You just have to use this one. So you go. Yep. It just moves to average into the file.
Like, that's just where I'm at. What to do, and I feel really stupid with that. So, I understand that, like, so these are the files that we're trying to do stuff with. But I'm not sure, like. How to use this to do that. Yeah. So do I just put in?
Yeah.
I'm not quite sure. I'll feel stupid because I don't understand what you.
I forgot my solution this morning. I figured it out again.
Okay.
So you can. Yeah, but without, I'll just, I'm gonna do it up there. Okay. Hey, everybody, I'm gonna explain now how we actually got there, and it's okay if you didn't get it. I actually wrote this a few weeks ago, and this morning I forgot how to solve it, and I had to look it up again. So it's fine. Okay, so using this, anybody get that first condition right? Figure out how to do it? Right, that's all that counts, right? So if you go if, so right now we have file name, right? And using the function that we had up there, right, starts with, we go down, starts. And then INF. Is that right? So it will go if, that first condition will say, if the file name starts with INF. The information ones, it will put it in large font, right? So knowing this, how is the second one gonna look? If I want to put the small ones in there, how is that second one gonna look? SMA, there we go. So you just copy paste exactly that, you go file that starts with the commas SMA, and it will give us the second condition, right? So the important thing for the ifs is to always remember that you want to find a true condition, right? We need a condition here that at some point with some of these will go through. In this case, the information. And we're copying that one to the second one. And putting it there. Also work with the if elif and it's put it on there. We didn't use the and the or. Or just threw so much at you and happened. Okay, any questions with how that exercise goes and how it prints out and what it's actually printed I don't have questions because I don't understand, or yes, I don't have questions because it's all right.
Yeah.
Or comma somewhere.
Oh,
It always
Yes.
misses me.
Colon. So you don't want to colon at the end of that line, you want to colon at the end of the line just above it, so with essence, so. You want to colon at the end of the.
That's-
and the end of the line. So- Yes.
Okay, sweet, yay, thank you.
Right. So I think the last exercise there, you can. To give it a try. If not- a lot of pretty. A lot of topics that could take hours by themselves to cover. Good. Yeah. We can call for the other half of this. First.
Example, if you have to calculate the average of a list, or if you have to convert a value to something else, then you do codes that you always kind of repeat. Now, instead of just repeating it, code you have functions. Functions is like a map. Basically, a unit. It's a function is something that if you have something repeatable that you want to just define in your own function. If you are a smart grad student and you write a function here, you can always use it in other programming. If you have multiple different programs, you can reuse functions. But the nice thing with functions is that just a little defined unit that does one task, and you just don't have to worry about it again in your code later. So what we're going to do is now look at some very simple functions, how to define them in Python, and how you can give parameters to them, and how to cut value out of them. So one of the classic examples is always the conversion from Fahrenheit to Celsius or reverse. Most people Celsius is, but for some people like me from Europe, we kind of are used to Celsius. So it's like you look at the weather and think, oh, it's 89. That's very hot. Like it's 28. So the first function is here Fahrenheit to Celsius. I can look on my Amazon dot thing, whatever, and it shows me like it's 56. So the function is the term def. Def is from definition, you define a function. And in this case, I call it far to Celsius. I could have typed Fahrenheit to Celsius, but I guess. It's the standard function temperatures in you subtract 32 and you multiply. In this case, it's a function and then you return. So in this case, I type this thing and run it. And nothing happens, of course, because it just defines it, just like if you add it. If you assign a value to a function or to a variable. So now I want to use it. Not a better number, but 32 is actually freezing temperature, so that's 0 Celsius. But if I say today it's gonna be 85. Almost 30 Celsius. 30, yeah, 30 Celsius. Yeah. We're in the middle. Value can be used in another function. Now, this is a very simple example. We use the return value of this part of Celsius in a print function. So then it just prints a nice string plus the temperature. So it will. First three arguments. One. The freezing point of water, it pulls the trunk part of cells at Celsius with the number 32 and the C. So it will say the freezing point of water as well, that's kind of right, it's 0. That's the outcome of two functions which we come. The functions can be very powerful. And in this case, we have to the kind of another conversion. If you're especially in physics and chemistry, you use Kelvin a lot because Kelvin is like absolute 0. It's just 0 is actually 0 and not like Celsius or Fahrenheit, where it's just some random defined temperature that's water is freezing or alcohol boils like Fahrenheit. In this case, you want to convert Celsius to Kelvin, which is basically easy because the Kelvin 0 is Celsius minus 273. So this is pretty straightforward. And now I'm using two functions I call Fahrenheit to Kelvin. So I have this function Fahrenheit Celsius, and I have a Celsius to Kelvin. So I think I'm going to be smart. I'm just using both in this function. Exactly what I'm doing here. Fahrenheit to Kelvin, I get a temperature in Fahrenheit. I first convert it to Celsius. This is a local variable called temperature Celsius. I convert that to Kelvin with this new function, and I return that value. So I'm instead of the function, I could have, of course, I repeat stuff. Why when I can use functions. Now, in this case, it looks silly because it's just you can from Fahrenheit to Kelvin, but it's just to show that you can use functions in functions. So I run this. Voila. First convert 212, which is, we know, boiling temperature in Fahrenheit to Celsius. So that's 100 degrees. And then I convert to Kelvin at 373 degrees Fahrenheit. So water boils at 373 Kelvin. It's out on your physics exam. Well, in middle school. To these things called temp C and temp K, and you have to define the scope. The scope of a variable is where you can use a variable. If you use it in your regular Python, your variable can be used everywhere. If you define a variable in your function, this only has its value in that function. So if I would say here, print temp K, it would give me an error that it doesn't know the variable temp K. It's only known in that function, which is handy because you can use an index I in multiple functions and they will not interfere with each other because they're all local. Now, using the index I or iterator I is usually a bad idea unless you are used to C. But in general, this you can have overlapping value names. So if I run this, whoop, set, the temp k variable is only known in that function and not in the main. So Python has a few scopes where we only touch about the main. It's there's going to be a very bad example where I use variables from the main scope in a function, which I'll tell you not to do. So this is kind of combining functions and variables. You call the function parent, which we did before. You assign it to a variable, and anywhere in your function you it's like your, I think you call it sticky notes. It's like the sticky notes. If you want to know the temperature and the boiling point of water oven, then you can save those local variables. All function or formula here. You don't have to keep calling this because calling a function. So Python just like it remembers that you just Celsius, it will keep that in its memory every time below. So like I said, you have this the local scope and the global scope. So you assign this variable temp Kelvin. So now it's a global variable. So if you would say use that in some function like this thing, it says temp Fahrenheit, temp Kelvin, maybe it's like. So now it knows these two are not global, it knows what to print. So here you say this function print temperature, here you define it. Here you give these global variables a name. Then print temperature uses these two values. So if I would run this. Numbers, because the temperature in Fahrenheit of boiling water is 212, and in Kelvin is 363. This bad practice is because if you write this function and you then suddenly you might not have defined this variable temperature Kelvin. If you look at the function, your colleague wrote this and you're looking at it because you're debugging a problem. You suddenly have no clue what these are. These are parameters to this thing. This can be a string for all you know. So if you're trying to don't know the program and you look at this and you think what's going on, if you use global variables, you can be completely kind of thrown off because it's not clear what it actually is. This is just an example of the scope of variables. Variables, so they are usable in the function, but it's very bad to use them because it can be very confusing. The best way to solve is just use parameters. So now let's get the same output. And you think, well, it's a lot of typing for the same output. it makes it much more clear if you just see this separately. If this function is defined somewhere else, you can see, oh, you have two temperatures and you print them both. So if I would really, if you are programming, don't try to use global variables. So let's go back to the NumPy. No, this will not work, you guys, but I just fixed it a little bit. So this is a larger function that loads a text file called file name. It does else if or an else. So this will basically load the data file and this does some checking on it. I will not go into too much what the max functions do in NumPy, but this defines the function. And here we're going to execute that function. So what I do is I say the file name is and glob is some way to look at files. It basically does all the information files .csv. And then for all these file names individually runs that function. If you've seen with Jose's thing, there's a little piece of text where you check for if the file is okay. Instead of doing that for each file individually, here it does. For file info, it finds 3 different files in my home directory. Information 01, looking suspicious. Information 2. One thing, functions can return a value or not return a value. In this case, it doesn't return a value, which is the only thing it's printing. I think we're going to go returns a value. So the finite tells you to return a value, but you don't always have to return a value. This is basically it returns none. Now, another nice thing with functions that you usually want to test them. So functions, you want to make sure that you have a little test case. And one of the test case, for example, with Fahrenheit to Celsius, you can give the temperature of boiling water because almost everyone knows that 212 Fahrenheit is 100 Celsius. So an easy way to test it is just call it with that number. You can also just do a little print statement for that. Later in this workshop, we go into debugging and tests. So in general, when you write functions, you want to make sure they work, you have a little test case, and then you just leave them there in your whatever you want. But there's also an important thing is documenting. Because testing, don't go too much in testing. This is you can one. It's much more complicated than just adding a few numbers. And you come back a year later and you think, what is this? You usually want to document. You want to say just a simple description. This is a border condition testing for my weather prediction model. Or this is here I do a medium on this statistical variable in the public data. So in general, you want to document a little bit. Now, there's a few ways you can document in Python. You may have seen the pound sign. If a line starts with pound, it's comment. But Python has this very interesting built-in function called help. Well, help with this argument, any function, it will give a little bit of help. So if you do type help on print, it will give you a little bit of description print does. The same thing with your own function. You can give it a string, and a string can be 1 or 3 floats. And so in this case, it's the offset mean, it's a description, return a new array, blah, 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 blah. Did we discuss so the difference between a single quote string and a triple quote string is that This 3 quotes because I want to have multiple lines of commenting. I come back a year later, I want to see what it is and not look through the whole code. If I do a help on that function. This is the syntax. So Python will print you the function header. And to show you that you can do this with all Python functions because help is very useful. Now this help, it gives a lot of output, of course. Because it's done. So I did help on helper. It says it's built in. And it will give you a whole list of stuff. How to use help. Now, I mean, this is not very useful, but any function you can do help. So if you start writing your own functions, and usually they are much more complex than times 200, make sure you add something like a help, because otherwise you might be confused. The wrong thing again. You probably should stay here. But this case of help, we actually put an example in. And especially if you have a complex math formula or whatever, and you give it to you. And it can be handy to put an example in. So here, a triple string, like a multi-line string, can be very useful because it gives you an example. It just says, what does it mean? So you define a function and you call help on that function, and it will give you the whole example. So someone who just came into the lab and he looks in the library with all this, your lab has this whole Python module, their own Python module. You can just do it. Just run that example and see what it's doing. Like I said, if you want to, the behavior of a function, you get parameters. Some of these parameters are always, most of the time they're constant. If you have a function that can read a comma separated value file, you can have different comma separated. Most of the time it's a comma. Sometimes someone gives you a file that has a plus as a separator. I mean, that's silly, but yeah, you can have cases where you comma separated value, the separator is a plus. So in NumPy has this thing called low text, and since the default is almost always comma, you say the limiter equals this. So if this case, it's this very array with all these things. But if you so if a variable has a default value and you want to give a value that's different, you still need to give that. Actually, this we will go a little bit further on, but Python gives us where your error thinks, and you just have to go through the list to see what the actual error is. Now let's start using our own default variables. So we have this offset mean where we put in data and we have a target mean. So this is the offset of the mean which your value is given. Now, most, you say, for example, most of the time you get 0, you just don't want to have an answer at all. What you do is start with mean value equals 0. That means if you don't give the variable when you call, when you don't give it a value when you call it. For example. This case is close. If you can. But if we leave out this 3, can you move it? What it did now is instead of that 3 value, it used 0. If I wouldn't have specified the default value up here, it would give me an error that there were not enough arguments. And suddenly it's missing one requirement argument. But if I say, well, it's almost always 0, I can set that as the default value, and I don't have to specify. So like I said, it says this is handy. If your function usually takes a standard variable, if the variable is almost always the same, but sometimes it changes, then you can have a default variable. This shows the same thing when we actually already run very. Yeah. You can have any amount of your parameters to your function can have a default value. So in this case, we have 3 A, B, C. And the only thing that doesn't print all 3 of them. Now this is really an example, but just to show. By default, display, it will just take the default and say 1, 2, 3. So the first case still use 2 and 3 for B. Still leave 3 to C. So as expected, you see 1, 2, 3. We have 50. 55, 66, and 77. Now, imagine I'm fine with A, B, 1, 2, 3. I'm fine with 1. What you have to do in that case, you have to specify. In this case, if you take C equals 77, it will recognize that you don't give a value for A or for B, and it will use the default value for A and B. So if you at comma B equals 88, why I asked it to do it after. It will give you 8877. And the same thing, of course, if you put A equals something, then it will just fill out this. So you name it. Therefore, Python is smart enough to see that even though it's the last argument, it's the first parameter to the function because it matches up with A equals. So this can be very handy if you have some large, if you have a function that takes a lot of arguments, but most of them are default value. You just name it. You can always use this, even if there's no default value, you can still name the argument. that you can use as help for anything, but you say you want to figure out how you have to load. So you can see here. Look, there's a lot of variables, but most of CBS has in different types. Comments, it's how does this parse, what the delimiter, what the converters are, if you do from one character set to another, if you do from Arabic to English. There's a lot of things that you can change to this function, but most of them just people don't care. Get the max rows done. They want to have as long as possible. If you really only want to read the first 4 columns, you can turn the max rows to 4. So this is a lot of default values. There's actually only one variable needed. That's the problem. So let's go down. And you may know the second argument was the limiter. It's the second we don't have to specify. You do have to specify. So you say the default is the file name is always mandatory. And then you change this argument to comma. So there's more to that if you want to make them readable. So you can do A, B, C. But then how do you remember what A, B, C was? Well, sometimes you want to make them readable variable names. You to C for Fahrenheit to Celsius. The same thing, you don't want to have this function because you write as you may know what S means, in a week, will you know what this means? This doesn't mean anything. The speed velocity or mass. So no, that doesn't make any sense. So what usually what tell you when you start coding. First of all, don't use global variables in your functions. And second, use comments. And third, use variable names that you can actually understand. Thirdly, standard deviation. Well, you know what standard deviation means. Sum of your samples. And the sample is your rate as you get here. So this you see, you look over the sample, calculate, and you have a sum of it, and then you do the. You can see what this means. The value minus pi blah, blah, blah. Go through it and see what it means instead of just v minus m. So this is a lot more readable, not only for others but also for yourself. Because what if you made an error? What if you did plus here? Oh, yes, of course. And it's much more confident. And for variables. Now, in all our tutorials, we use underscore. There are huge debates what kind of you use. You have to just stick to yourself. Some people that have uppercase names and where you kind of sample uppercase M or whatever convention, but just try to stick to yourself to the same one. Here we did it simple and underscore sample underscore mean. It's because sample mean to mean. So yeah, there's still after 500 years of programming, people are still debating what the best method is. It doesn't matter. As long as you stick to your own methods. Of course, that if you're a programmer in a big company like NVIDIA or Microsoft, you have to adhere to their standards. But for your own work, try to be consistent, and that's it. You have to reach your own. the standard use names that make sense to you. Because some people just have no clue what div is and they want to just write it out, deviation, whatever, or standard. No, standard STD, I know what it means. So just what makes sense for you, but try to think of yourself in a year when you want to read back your work. So add these multi-line comments. If you know that your code is going to be used by others, put examples in there if it's complex thing. It's just the second one is a lot more readable. The first one, this. So yeah, so this is kind of. So like I said, they are the same functions as standard FTD, the same. Like I mentioned before, some functions give you an argument back and some don't. Well, actually they give, but they give the value none back. So let's do a little bit. So this function, add A and B, and what it does is adds them up and prints the value. So if I call, it will print 10. Now it assigns this to A. Doesn't return anything, it returns none. It's not undefined. If you would print A before, that's in Python, the concept of none means really nothing. It's not undefined, it's just nothing. Return A plus B. Then, of course, prints 10. So, when would you use a return variable and when none? Well, it's most they use a return variable, but it depends what the function does. If you just want to load a variable, no, yeah, almost always you want to return it. If you print something, if you make a debug statement, then it's not. Also, if you go furthermore in programming, it's always handy to return a value just to say that the function succeeded. You want to know in your main code if it succeeded. Now I'm a C programmer by training, so I do that by default. In Python, you have more elaborate mechanism to catch errors. If you have a function that loads something and something doesn't exist, in C you would return -1 or -. But it's always kind of good to check for errors. But we will go into that in. Which has 4 arguments, and 2 of them have a default value. 2, 3, 4, and 2 are the default value 2 and 4. And what happens here is I convert them to a string and I add them up, and then I return that. Now, if I run this, with 1 being the first one, and I do is paired with arguments that have default value, but it's not that small. So paired arguments with a default value in the function. So what happens here is, for some reason, it doesn't like that 3 doesn't have a default value. So the easy way to solve this no, 1, comma 2. Now the naming is a little bit weird now, but you have 2 arguments with no default value, and you have 2 with a default value. This because arguments with a default value has to be n. They will actually know how to figure out what is what. Now, why does it get a string? Well, because you convert it into string, and if you add a string up, you then add everything up together. If you would say 3 equals 4, you would get 1, 2, 4, 4. If you have arguments, always have to be the end of the list. It doesn't really matter in what order you get the arguments. You can, if you're going to use this, actually, the nice to say 1 equals 1, but whatever. It's sometimes it's hard to be consistent. B equals 3 with B. Is print. There. So with the 1 is the first argument, and with minus 1. 2. Print 1, 2, and 6. Language. Now we're almost at the end, so we have one more exercise. I'm not sure we have time for this. What you can think about this in your break. So we have this function called fence, which adds 2 strings. So this should be relatively straightforward. Arguments, say A and B, and you print B plus A plus B. With that, I think we're gonna go into a break session, which is also called lunch. So lunch is on your own, and we're expecting back in 1.5 hours. I would tell you one thing: your desktop is open, but you log in. So I would advise everyone to lock the screen. You can leave your browser open. There's there. In Windows, the easiest way to lock is the Windows key and L, where you just go into the Start menu and look for your name and click and click and click and click and then to lock the screen, and then we'll be back. Do we close the room? Charge here. But if there's any questions before we go, no. Does anyone have questions? I'll show you how to load it.
All right, everyone, I'm Alex Townsend. I'm one of the application specialists at RCC. So in this session, we're going to be going a little bit more into depth with lists. And we're also going to cover a little bit about how to deal with error messages and how to read and how to read and handle. So Marcelina talked a little bit about lists in the first session. Basically, a list is sort of a collection of objects, and you can use them to store various values, and you can use them to store various different objects, and they're really nice because you can group things together that way, and you can sort of have them have them all in one place without having to worry about without having to worry about scattering. So, like that thing for you can also store values that are related to one. So think, for example, like you've got a bunch of temperature readings from a temperature sensor that's like sitting outside your office or something. And that sensor takes readings every hour or so. And you want to make sure that you keep a list of the times that it records and another list of the associated temperature readings in Celsius. So, for example, you can actually define two lists like this. One will contain the hour. In this case, it's 24-hour time clock, but it could be anything. It will contain the hour at which the data was recorded, and the other one will contain the temperature that was recorded at that time. So basically, in this sense, lists are useful as items as sort of bags you can put related items into. So, for example, so it's a quick exercise. Try to create two lists based on what you learned in the first session, and kind of based on that out of these lists. You've got a different sensor sitting right next to the temperature sensor outside your office, but this one measures humidity at the same interval, one measurement every hour, and you want to keep a list of the hours that the sensor recorded the data, and you want to keep a list also of the actual humidity values that you recorded. So how would you go about storing? And if anybody has trouble, just let me know. So those two lists that we defined, those two lists would look pretty much exactly the same as the two lists we created before for temperature and for time. The only difference that one of those lists now contains humidity as opposed to. So if you want to print those items, those items in your list out, there's a couple of different ways of doing that. The first one is the one that you learned back in session 1 with the four item in list loop. Another way is to use index. So in general, every list in Python has associated with it a number that indicates its position within the list. So if we were going to say for I in range length of temperature readings here, what this would do is it would say, well, give me the length or the number of temperature readings in the list, And this range function will say, give me a list that includes all numbers from 0 to 1 less than the temperature readings. We'll get into why it's 1 less in just a minute. And then what this I here is an iterator. So this will act as a variable that will get updated every time this for loop goes through. And then what we can do here is we can say print that time I. When you put I in brackets next to the name of the list, it will select a single element out of that list. Then add the temperature readings of I Celsius, and in this case we're telling Python to take the index or the elements stored in the variable I of the time and temperature readings variables and print those out to the screen. And since I updates from 1 to the total number of elements in the list, since that updates every single time in the for loop, it will actually we'll get all the values out there. So the other thing you can actually do is Python print statements are pretty powerful. You can actually print out the entire value, the entire list in a print statement too. So for example, you can say print the times the sensor recorded data time at the end of that. And what that will do is it will simply concatenate all of the elements in the time list to the end of the print statement. And you'll get something that looks like this: the time the sensor recorded data, and then all the hours in the times list. You can then do the same. In general, the second method where you just print out all of the elements in a list at once in one print statement is good for quick displays of data, and it's also good for looking at the structure, the actual internal structure of your data. If you're just working with simple lists, the structure doesn't usually get that complicated. But when you get into bigger and bigger structures like classes or data or other data structure types, this can actually be really helpful. So as a quick exercise, using the humidity sensor data list we created in the previous exercise, print out both the time and the humidity readings list using both methods described in the section. So the first one was write the for loop version, and the second one the first one is just write 2 print statements, one that prints out or just write a print statement that prints out all the humidities in the list, and the second one is print the for loop version.
I ran out of time, wasn't able to explain in session 1 was the range function. Of length of the temperature readings. So we talked a little bit about what length was. The length function pulls basically how many elements are in temperature. What range does is it basically creates a list of all the index values. So the index values that were invisible before, to just say, this is the 0th element, this is the first element of this list, this is the second element. This actually will just create a mini list that you're actually can show you. So the range of the length. Goes up as 0, 1, 2, 3, 4, and 5. So as you're going through as I in this for loop, I will be 0, 1, 2, 3, 4, and not including 5.
the range function really just defines the boundaries. Of the iterator, so it can't be less than 0 and it can't be more. It's the range function of for loop. It will start at 0 and it will end at 5. Yeah, so again, just based on, so again, the answers to those two quick exercises are you can just type print humidity. That will print out all the values in the humidity list. And you can also do for I and range length of humidity, print humidity of I, and that will print and that will go through from the first index to the last index in the humidities list, and it will print out every value of the humidity. So I wanted to mention is indexing. So I mentioned before that the index. So as we mentioned before, the index starts at 0. In general, Python and pretty much all programming languages that have lists or a structure that's similar to that, those lists will have associated with them a number, a set of numbers, and those numbers will indicate the position of each element within that list. You can kind of think of that as like if you've got a shopping list or a list of items that you write on a piece of paper, you might see, you have item 1, item 2, item 3, item 4 on a piece of paper. But Python lists work in exactly the same. You have a bunch of items, and each item in that list has a number associated with it that indicates its position within the list. Now, it works a little bit differently than, and most programming languages do. They work a little bit differently than the way, in terms of how they number lists than we might ordinarily think. All lists in Python start at item number 0, as opposed to item number 1. So in that case, all of the indexes are sort of shifted down by 1. So if you have 5 items in the list, the index for item 5 is actually 4, because the first item doesn't have the index 1, it has the index 0. So you go 0, 1. So for indexes, you go 0, 1, 2, 3, 4, as opposed to 1, 2, 3, 4, 5. Are there any questions on this stuff so far? For example, if we wanted to go through a couple of examples with indexing, if you wanted to print it, going back to the temperature readings example we had before, if you wanted to print out the third temperature that we recorded, you wouldn't use temperature recording of temperature recordings of 3 with the index 3, you use the index 2. So in this case, you could print out that the third temperature that recorded was 23.2. Now, if you print out all of the temperature readings, you'll notice how this 23.2 is actually the third element of the list as opposed to the second. Like you might think. Again, this is just to reinforce the idea that indexes are all shifted down by 1. So index number 2 is actually the third element. Index 0 is the first element. Index 1 is the second. So I probably use this term. So I added this here just to make sure and reinforce this, but I probably already used this term before. But the term index is really important. You know, if you go through other programming courses or you read more about programming, and you learn about lists, you'll hear the word index all the time. The term index or indices really just refers to the order number in the list. So item number 0 is index 0. Item number 4 is index 4, and so on and so forth. It's just a label that indicates. It's just another way of saying the label that indicates that an item is specific. One thing that's interesting about Python, and this is actually not true of many other languages, but it is true of Python, is that you can actually use negative numbers as indices in Python. And what that does is it says, okay, so 0 is the first element in the list. But what I do if I go backwards is I move all the way back around to the end of the list. And so the minus first index is actually the last element in the list. The minus second element is the second to last element in the list. So it's so the indexes are kind of circular in this sort of way. In using negative numbers, they can be kind of circular like this. This is not true of the positive direction. So for example, this can be kind of useful though, because for example, if you wanted to print out those temperature recordings in reverse order, you could say for I in range length of temperature readings, at time negative I, the temperature readings negative I. Now you notice that the first one here is still the first element of the list. That's because the range function will always start at 0. So in this case, -0 and 0. Right? So this is always going to be the first. But then the next iteration is -1. So it goes to the end of the list. Second to last. Then the third. Now, if I wanted to print that out in a way that was actually in completely reverse order, what I would do is scroll down a little bit. I would say for I in range 1 to length. It takes that range function and shifts the indexes back to what you would kind of think they would ordinarily be in a regular like shopping list or list of items. This means that the range function, when you start using I as an index, the range will start with 1, and it will go all the way to the total number of elements in the list, as it would actually be if you counted them. And the result of that is you'll get everything in reverse order. So, as a quick exercise, again, using the community sensor data you created in 3 lists, print out the following information. The 4th item in the community readings list, and all of the community readings.
I use one. Say right out minus one. The opposite goes from 0 to 4.
Yeah.
Especially.
Yeah.
File things. Go right.
Check to make sure I done it.
Create a list. Create a list of big items. Sort of returns list an anonymous function that sort of and that is like listing functions.
Over the solution quickly. The answer to the first one is pretty much exactly what we saw earlier. Just print and then the humidity list and index 3. That will give you the fourth element of the list. Because the positive indexes, when you're not trying to print things out in reverse order, the positive indexes always start from 0. So in this case, 0, 1, 2, 3 gives you the fourth item. Then to print all the items in reverse order, we've got to shift the indexes up from 1 to the total number, and then we have to use those negative indexes. Because if we have -0 and 0 are the same number. So Python will always look at that and say, oh, you want the first element. So you want the negative first element of the list. So Python has to see negative. it -1 in that index, not -0. For I in range 1 to length of humidity +1, front humidity of I. To give you all the humidity in reversal.
So if I just do simple print humidity, I know it just lists out like in. All the numbers. Is there a way instead of having like rough elements, I could remove the order in that order model?
Yes. So the way to do that actually, and I'll show you. What you could do with that is you could do print. Humidity. Yeah. So you could do print humidity. Colon negative, I think it's colon negative colon. Yeah. So it's print humidity colon -1. And what this will do is, what this colon -1 will do is it'll just reverse the list. Yeah. Yeah, so it will return an integer, but the length integer will start counting from 0. And so +1 is if you started counting from 1.
Optional parameters before. And so what you can do is you can give range 1 number so that like when we were giving it before just length, which basically says like, yeah, it'll start at 0 and then it'll end at whatever number. So the starting number, we're now setting it as 1. So now it also needs an end value. And so to make sure that it includes all of the numbers, because the length, if we only go through 1 to the length, then it's, so for example, like if it's a list of 5, then we're only going from 1, 2, 3, 4, and then we're not including 5. So what you want to do is you want to set it to 1, all the way up until 6.
Yeah, so in the positive direction, you always start counting with 0. So the final index will always be 1 less than the total number of elements in the list. You go in the negative direction to try to reverse it. You actually start counting 1, and so the final element of the list is actually the total number of elements. But the length function always returns the number of elements of the list, pretty much counting from 0. Oh no, I'm sorry. The length function will always return the total. The length function will return the total number of elements in the list counting from 1. But the range function will automatically do that subtraction. So in order to make sure it doesn't do that, we have to tell it, no, add that 1 back in. We actually. Any other questions? So don't just have to contain numbers. They can contain any type. They can contain any data type you want. So lists can contain. So for example, if you have a gene sequence with the bases AACCAA, where each item is just the character for one of those bases. And you can do that, with this function. You can do that with this code by just defining a new list, and each element of that list is just then one of those bases. Also, if you have a list of programming language names that you wanted to group together, you could also. So those would be, each one of those programming language names are multiple characters, so they'd be strings. And as a result, and actually you can put a bunch of strings into a list too. So for example, you can have C++, Python, Perl, Rust, and Java. Python, now this is actually an important difference between Python. Now, we'll get to an important difference later in Python between Python and other programming languages. In almost all programming languages, you can have arrays of you can have lists where all elements of the list are the same type. But we'll see in a minute, in Python, you can actually mix and match the different types of lists. This is not true in other programming. So as a quick example, so create a list of items for a shopping. So you want to go to the store and buy apples, oranges, grapes, and cream cheese. And try to make a list out of these items. So just to quickly go over the answer to that, to create your list of shopping items, you just create a list of strings, and then in order to print them out, you could just print the entire list out of the string. Yeah.
We're gonna learn how to like read in the values for a list. Like so instead of just having to list out everything like that,
Probably not in this section.
Last session, in session 2, when you guys were sorting through the file names, for the starts with and ends with, how you can add it, at least in like an individual sense, like element by element, is putting the list name dot append, and then whatever the element is that you're trying to add. So for example, on the shopping list, I guess right, so that's a way that you don't have to type it in altogether, is the append statement. But there's a lot that are similar that can take in that input value, that variable, and then append it to the end of your list. If that answers the question. Yeah.
The next topic we're gonna go over briefly is a concept called mutability. And mutability is a term in computer science that basically means the ability, that basically refers to the ability to change an item. Right? And in computer science, there's basically two different types of data. There's mutable data and there's immutable data. In Python, lists are mutable, which means you can change the individual elements of a list. However, a lot of other data types in Python are immutable. So for example, strings are immutable, which means if I want to change the individual elements of a string, I can't do that without completely redefining the string. So for example, if I print out the list of programming languages again, like C++, Python, Perl, Rust, and Java. Can you just run that? Thank you. So if I want to change the first element from C++ to say C#, which is another programming language, I can say languages of the item at index 0 of languages now equals C#. And if I print out the list of languages again, you'll see that the first element has changed from C++ to C#. However, if I wanted to change, if you look at the last element, this list Java, if I wanted to change the J in Java from uppercase to lowercase, one way you might think you could do that is by saying languages, take the fifth item, the last item, the fifth item, the first item in the string, which is the first character, and change it from uppercase to lowercase. Python is going to have a problem with that, and it's going to say, it's going to give you this type error that says string object does not support items. Hey, you can't change individual letters in a string. You have to completely redefine. You've got to update the whole string. So if I wanted to change Java from uppercase to lowercase Java, could I ask a little bit further? I have to redefine the entire final element from Java with an uppercase J to Java with a lowercase J. That's kind of that's the basic idea of what's meant by mutability. You can change the items in the list, but you can't change the individual letter in the string. You scroll up a little bit, and in general, if you run into a type error that looks kind of like this, and you see something that says something like object does not support item assignment, there's a good chance that that data type is actually immutable. And what you need to do is actually, and if you're trying to change an element within that data type, it's more, and you get that error, it's more than likely an immutable data type, and you need to redefine the whole thing, the whole variable itself. So I'm going to skip the exercise because I'm going a lot slower than I thought I would. So I'm going to try and speed up a little bit. But there's exercises for every one of these things in the workbook. And during the break, if you want, I'm more than happy to help you out. So I alluded to this a little while ago, and it's that in Python, lists can contain multiple different types of data. So for example, you can have a list that has the integer 1, the real number 1.0. It can have Boolean values like false and true. You can also have a character, and a string, and you can have all of those in the same list. This is not true of other programming, of many other programming. In many other programming languages, you'll get an error if you try to do this. But Python is nice to you in the sense that it'll let you do this. With Python is something called nested lists. In Python, you can actually make lists of lists. And what that means is what that means that you can have a list where each item in that list is itself a list. And this is a good way of representing things like data matrices or large data sets where you can have it where each item in your list is itself a row of data in a big data table. And then each item in that in each of those rows represents the value of one of the columns. So for example, we could represent items on a bookshelf. Like I could say on the top shelf, where in this case, each list is each item in my list is one shelf in my bookshelf. And so for the top shelf, I have physics, Python programming, and chemistry. In the middle bookcase, I have finance, F# programming, and economics. And the bottom shelf, I have geopolitics, C++ programming, and GIS. In a picture, it might look something kind of like this. I mostly did ASCII art because I was not about to draw that. So if we wanted to print out the bookcase, we would get something that looks kind of like this. Python will put all of that into one line. There are ways to make that look nicer, but in general, what you have just remember that first item is the top shelf, second item at the bottom, the middle shelf, third item at the bottom. So shelves in this bookcase. In this case, if I were to print out the first item or item number 1, or item index 1, which is the second item in the list in the bookcase list, that would actually give me a whole nother list, which would be the middle shelf. In this case, I get a list of finance, F# programming, and economics. Not the last book on the middle shelf, and not just the whole middle shelf. Well, in Python, you can actually chain indexes together. So what this statement here does is it says, take a bookcase list, and then give me the second item in that list, which is going to be the middle shelf. It's going to be a whole list. Now within that list, give me the third item in that list, which will be the third book on the shelf. That'll do is it'll print out the economics, which is the third book on the middle shelf. So if you've got lists of lists, you can chain together indices and individual items out of your innermost list, and at one list which is itself a bigger list. So let's say you want to add something to a list. In Python, you don't necessarily need to know ahead of time how many items you're going to need to store in a list. This is another thing that's true of Python that's not always true of other programming languages. In Python, you can actually dynamically add items to your list. Other programming languages make that a little bit more difficult. But in Python, for example, if I wanted to add a fourth book to the first shelf, say I wanted to add a biology book to the first shelf, all I would have to do is say, okay, give me the top shelf, which is bookcase of 0, and now add a new item to the end of the list that I get from the first shelf. Including a biology book. So we can verify this again by printing out just the top shelf. And you'll notice how this So. If you want to remove items. And also, you can do that. There's a couple. Do that. The easiest way to do. So, for example, if you, what the pop function will do is it will remove the last item in any given list. So for example, if I wanted to get rid of the third book in the middle shelf, I could do bookcase of one dot pop, and it would tell me that, and it would what it would print out is it would tell me, okay, that's the economics book. Now we've popped that off of taken that off the shelf and throw the book away. So if we now print bookcase, the middle shelf of the bookcase, now there's only two elements in that list. So the pop function is really nice because it allows you to really easily take items off at the end of the list. However, another thing you can do is what do you do if you don't want to delete the last element in the book in a list? What if you want to delete something else? Say, for example, you just sold the physics book, and the physics book was the first book on the top. So we can't just use pop, because if we use pop, we're going to have to delete all the books and then re-add them later. So what you can do is use the del command. And what the del command here does is it specific, and it will remove that index from the list. So I can say del bookcase 00. Top shelf, and I can delete that item. Now if I print the bookcase out now, if I print the top shelf out now, the physics book is missing. And that's exactly what we wanted to achieve. So those are the two main ways of removing items from the list. Yeah.
Pop function, we remove that one book instead of that entire shelf. Just automatically.
When I told it bookcase 1.pop, what that does is it takes the first shelf off of the bookcase, or it takes the second shelf off of the bookcase, the middle shelf, and then the pop function is applied to that list, not to the whole list.
It's not the last element.
Yeah, and then pop will just take off the last.
Next one.
Yeah, so if I had just said bookcase.pop, it would have deleted the last. It would have deleted the bottom shelf. I don't know, but let's see. Yeah. So, yes. To remove a specific index, but the default is just to pop the last element. And so the default is -1. Yeah, the default is -1. And so it's a little bit clearer and easier to understand, and just easier to understand to do pop for just the last element and del for really specific elements. If you wanted to, you could use pop for specific elements, but I'd be careful with that. Just because you'd have to make sure the index. Any other questions? So another thing we want to do pretty often is reorder items in the list. Now we saw earlier on that you can print out the items of a list in reverse order by using negative indexes. I also showed we also showed that you can simply print out all of the items in a list in reverse order by using the ::(-1) syntax for a list. However, if you wanted to truly reverse the list and not just print it out in reverse order, if you wanted to save that list in reverse order now, you could use the dot reverse function. So for example, let's say I wanted to swap the geopolitics, C++, and GIS. What I could do is say bookcase of 2, which is the bottom shell. And now if I print the bottom shell, you'll see that that geopolitics and GIS have swapped. This is actually a really useful way of reversing information. So for one place this might get used a lot is complementary sequences in genomics. This what if you use this function, it can be real easy to just get the complementary sequence by reversing the main sequence if you only have one. So a quick warning about list names. There's something to keep in mind. Remember earlier how we had the name function. We had the name function like Rosalind, and then you iterated through it, and then when you printed out at the end, it was Turing. Well, lists work in a way that's a little bit different. So for example, I have this list of programs. If I then assign a new name to that, I say code legs equals languages. What this will do is it will not create a copy of that variable, like it might with individual strings or. What it will do is it will create an alias for the same variable. So essentially, what you have are two variable names that are pointing at the same set of data sitting in the computer's memory. So now, for example, if I print out code lines with languages, I'll get the same list. However, if I reverse the code lines list and then print out both of them again, you'll see that both lists are reversed now. That's because both names are actually referring to the same item. So anything I do to one name will affect the other. Now there's a way to, if I use the one item from code lines. Now there's a way to get around this. If you actually want to create a new variable that is actually a copy of the original variable, you can use this syntax. So I can redefine the list of programming. And then I can say code lines equals list languages. And that'll do is that will do to the code lines list will not affect the language. That's just a quick caveat. So be careful. Be careful about that if you're not. Out on time, so I'm going to skip to the error handling section. Okay, so the next section we're going to talk about briefly is errors and error exception. So earlier on we solved this error, this thing where we had before I questions about strings or lists or gets. So errors happen all the time. I mean, I've been programming for years and years, and not a day goes by where I don't have some error message. If I don't see many error messages when I'm programming, something is then I get really worried and really suspicious because I'm not that good in the pro and I'm sorry, and then I start to worry if Python's broken or something. So in general, errors will look something kind of like this. And there's a couple of different types of errors. There's a general error message, and then there's something called a traceback, which we'll cover in a little. A general error message. So error messages in Python are really nice because they'll scroll back up a little bit. Because generally they'll tell you what the problem is, even if that object does not support item sign. So what they're really saying is, hey, you can't, strings are immutable, you can't change the first line of that. But what's really nice about this error message is notice this little arrow here. It's that line of code that actually caused the problem, where the problem actually was caused. And this is the first, this is one of the first really important things about error messages. Python is really nice about these. Other programming languages, not so much. Some languages are very good at it though. And so scroll down. So in general, all Python error messages will come with something called a traceback. And a traceback is exactly what I was saying. A traceback says, okay, so this is what the error actually. Now the traceback will say, okay, this error happened on number 2 of a specific code block or line number 2 here. And it will tell you, and then it will tell you exactly which line it is. And so from that, you can kind of think, because string object is not support item sign. And you can look at the methods on line 2 and think, oh, I tried to change one of the letters. So it must mean that it must be saying that would be a way of looking. That would be a way of getting a hint that maybe I shouldn't be trying to change one individual letter in the string. I should be trying to change the whole string at that index. So each traceback has a number of levels. The arrows. So for example, if you have an error message that says, okay, this error message happened in a function call, but then that function call also had another function call. I think Paul had one good example where you got this really, really big traceback and it was pointing at multiple different functions. So those are actually really useful because what it will generally do is it will start at the first place. It will start at the first place where it'll start at the first function call that actually returned an error. And then it will go a little deeper and say, okay, within that function call, another function was called that returned an error, caused the first function to return an error. And that can go many levels deep. And Python will usually go all the way down to the point where you actually find the offending piece of code, line of code that actually caused it. So if you scroll farther down. So I didn't provide an example. Oh. But in general, long tracebacks don't necessarily mean that there's, if you get long tracebacks, that doesn't necessarily mean that there's a big problem with your code. It generally just means that there's an error several functions deep in the code. And you might just have to start at the first function and then go walk through the traceback and go through each of the functions and see where the actual problem happened. And then from that you can usually see things like, I tried to assign a string variable when I shouldn't have in this one. To add a number to a string in another function. Or if you're me, you find after 6 hours that you missed an apostrophe in your code. So. if we go farther- Yeah, so there's a number of different types of errors. We looked at one already, which is a mutability error. However, one of the most important ones, one of the ones that I personally run into all the time because I always forget those colons, is now if I start writing a for loop and I forget to put a colon at the end of this line in for loop, and I try to execute this block of code, Python will say syntax error, invalid syntax. And then it will give a little caret symbol to. And from that I can look at that and say, okay. Another type of syntax error that can happen is unexpected indents. Now, Python is very different from other programming languages in that the way that it handles blocks of code is through indentation, as opposed to other programming languages. Like if you've ever used R or C++ or R, for example, R will use these curly brackets to denote blocks of code. In Python, those curly brackets don't exist, and instead it's denoted a block of code is defined as code that's indented by a single attack. Now, if for example I define function here that says add to, and then I indent it by one tab I'm supposed to, but then I actually over indent the return statement, Python will say unexpected indent will a unexpected indent, and it will give me this nice little caret symbol that says Python is that Python gets very pedantic about exactly how you indent things. So for example, if you use tabs for part of your code, like if you indent if you indent a function with tabs, then you go down a few lines of code and then start indenting with spaces, Python will throw an error because it doesn't like it when you mix spaces and tabs. This is kind of what will happen. In Jupyter Notebooks, you have to really force this because Jupyter Notebooks will try really hard to prevent you from doing it. But, for example, if I were to use tabs for the return function, and then if I was to use tabs for the return function, but spaces to indent message and print, I'll get something called a tab error, and what it'll say. That basically means that's basically telling me to make up my mind. Do I want to use tabs or do I want to use spaces? I've got to pick. So the third type of error that is name and identifier errors. So for example, if I were to define a function called name identifier errors generally come up if you use a variable but forget to define it. So for example, in this regress function, if I and an x coordinate, but I never defined beta ever. And then I try to use it, it will say, hey, wait a minute. You call this function regress, which created an error, which threw an error. And in the regress function, there's this line of code with a name that I've never seen before. So in this case, you actually have a 2-level traceback. the first level here says, here's, it says, this is the function where the error happened. And within that function. So you can fix that in a couple of ways, either define data within the function or accept data as another parameter. Here's a fix there. So another thing that can cause this kind of error is if I meant to print out a string, but let's say I forgot to put quotation marks. Maybe it's 2 a.m. right after I found that missing quotation mark. And I really need to go home. I typed print Java, but I didn't put quotation. Well, Python's going to throw an error and say, I don't know what Java is. That's not a name. Oh, I forgot to put quotation. So I can just fix that. Another thing that's really important is spelling and capitalization. In Python, if I misspell a variable, it will give me the same variable is not defined. If I accidentally capitalize like a variable hello, it will throw an error because it says I don't know what that is either. Now this is interesting because some languages are not case sensitive like this, but most modern languages are. Python. The other very common error type is list indexing. So for example, if I have 3 items in a list of books, GIS, C++, and Python, and let's say that I thought I had 4 items. Say list index out of range. I see this error. Personally, I get this error all the time. You're trying to access more items than there are on the list. So in that case, I just have to fix. In that case, it just have to fix. And there's a couple of different ways to fix it. I can either add another item or I can fix it. File operation errors. If I try to open a file that doesn't exist, I will get a file not found error. If I try to open a file in the wrong mode, if I try to open a file but I use the W mode, which means write, as opposed to R, which means read, it will say I can't read that file. You tried to open it in the mode that you tried to open it in such a way that that file in such a way that I was supposed to write stuff into it, not read stuff from it. So that's when you get that unsupported up. I think I have like five-ish minutes left, so I know I went through a lot of information quickly there. So questions? And that questions? Yeah.
An operation question. If we were to do the exercise later, is there we can access answers or I want to take more work.
Yes, because
So we'll distribute the link to the video later on, but so the zip file. They're
Yeah.
already online, but I don't know the URL. We'll just somewhere in the chat, but we'll send it by you.
yeah, and we'll make sure to remember to provide answers.
Yeah, I'm looking at this.
I'll put a note in our channel to make sure of that. And
If
if we did forget, you can always email us and we'll be more than happy to give you the answers. Yeah. The email, Marcelina will type the email. So that's our email address if we have it, if we forget. I'll do everything I can to make sure I don't.
Will be disabled probably shortly after this workshop. But it's very easy to get an account on our system. Everyone can get an account. So,
But we'll send those out. We'll send all of these notes out separately. So even when the workshop accounts get deleted, we'll make sure that you get all the files that are. Questions, then we've got a 15-minute break, and then session 4 we'll just go over some extra stuff with different numbers.
Yeah, we'll see you back at 3 p.m. So this last presentation is we'll be jumping back and forth between the three of us. Jupyter features, and so how can you code in Python? You guys have all been using Jupyter notebooks all day. And I did mention briefly create Python code in Notepad. This is a different example of Python coding in Python idle, where everything you write in here is code, and then you will meet to how we have the code blocks in Jupyter notebooks. And the farther you scroll up, you may not get that information back. So there's not a lot for specific tools and specifically you can install Python packages. As we've mentioned before, with NumPy not working, Anaconda makes that process a lot easier because it'll install things and it's open source, so you can interact with it outside of just typical Python. Or integrated development environment. So how is this different from just programming in Notepad? So Notepad, when you're typing in the code in the terminal, it doesn't have any extra features. So your own devices, and then if you run it in Python, it gives you an error. You have to go back and like fix where that is. Like Alex mentioned, sometimes they will give you extra information on where exactly that error is. There's actually so that can give you little icons on the left-hand side of the screen to say, oh, there's a semicolon here, or a colon per se, or your indentation's incorrect here, even before you. Different colors that you're seeing in Jupyter Notebook, that's an added feature and not something that you generally get in Notepad, because if you're just typing a document versus whether you're typing highlighting isn't going to get recognized in Notepad. And a lot of coding practice, but good coding practice in general. When you click tab on some of your variable names, if you rest of the name, so you don't have to remember all of the let's hope for temperature readings and like that. Version control, extra feature of an integrated development environment. And familiar with Git or GitHub, it basically keeps track of the changes that you're making in the code with timestamps and everything. So when you're saving, it does not have this feature, but when you're saving, you're collaborating, or like when you add this code, so like if you add a function at one point, you save it, you come back, you're like, when did I add this function? What does it do? You know who to blame. Outside of integrate or outside of plugin, but that's not a guarantee. On the next couple of slides that talk about either code editors or IDEs. Some of them have Python support, some of them don't. These are code editors that are just a little bit fancier than Notepad. And that's what you'll typically see as just straight Python code and not in a Jupyter notebook. Code from Notepad into just a console or just a terminal output afterwards, or as what your code is actually doing in Python. A lot of it. VI, Bin, and Emacs are more similar to Notepad, but specifically within the terminal. General IDEs with Python support. Outside of Jupyter notebooks on your own that you're interested in. There's a lot of windows and a lot of things happening. After that we coded up, and then the top half is debugging. An important part of this that's not and basically what it does is, remember how we were talking about when you are creating variables in Jupyter notebooks, just remember and make sure what variables you're using. When you run any code in this, Eclipse will do, and a lot of other IDEs. That matters in most programming languages. What type of variable it is. So you don't always have to add in print statements, and you have a little window that tells you that these are what you're going. IDEs or so extra integration to run Python. So this and it's that same that is in variable, the values that are in the variable. So if you're trying to print it all out, to use the range length, you know how much is going to output. As you can see here, there's multiple Python files. files on display. Projects, you want to. Let's see. So I mentioned Anaconda itself as a distribution of Python and like a really nice wrapper around it. Anaconda nav. I think it's a spider with very small font. And then and PyCharm as well. So or configuring it, how we are hosting Jupyter Notebook. And the reason that we talk about don't want you to come out of Python Bootcamp to say, okay, I know how to program in Jupyter Notebook, now what? Like, can I use this knowledge anywhere else? And there are free that are usable. It would just take downloading it onto your computers and then running with it, because you guys know how to program Python now. Let's talk about debugging.
Okay, so we talked briefly before about the different types of errors you can see in Python and different error messages. So those error messages are really nice. However, there's a different kind of problem that can go up. And those are the kinds of problems that, and those are actually the kinds of problems that I ran into when I was telling that story about the apostrophe that I took 6 hours to find. The reason I took 6 hours to find it is because that missing apostrophe was actually in a MATLAB program, and it did not break the code. So I did not get an error message. I just kept getting the wrong answer. And I couldn't figure out why. There was no error message. And so, well, what gives? So debugging is another level of error correction of fixing errors in your code. These are pretty much the errors that either you make or that are made or that you don't see until you try to put certain types of information in your function. And these are the types of errors that won't necessarily have an error message associated with them. They're just the errors that you'll notice when you try to run the code, and then all of a sudden you get a weird answer. And you wonder, why did you get that weird answer? So in general, debugging is not errors and exceptions. Debugging is fixing logical problems in the code. It's figuring out why your code gives the wrong answer, even though you're not getting an error message. Sometimes it's figuring out why your code gives an error message sometimes, but not always. The idea is basically look for problems and try to fix them. Don't try not to make random changes. Try to go very, very step by step and very systematic. The easiest place to start is to, if you have a big complicated data set and you run your code on it and you get an answer you don't expect, cut down the data set. Find a really simple small test data set where you know what the answer is supposed to be, and then run your try to get a few of those, and then run your code on those, and see if you get the right answer on those. If you get the right answer all of the time, then that's an indication that the problem might actually be with your data set. If you get the right answer some of the times, but not all the time, then there's likely an issue. There's likely an issue with the code. And if you get the wrong answer all the time, then there's definitely an issue with the code. So the concept of comparing to an oracle, that's pretty much exactly what I was talking about. Take a data set where you know what the answer is ahead of time. The oracle in this case is the answer you know ahead of time. And run the data through the code. If the code, if the answer the code gives you doesn't match up to what you know ahead of time, then there's definitely problems with this. If you're working in a physics setting or engineering setting or a place where you need to worry about conservation laws, checking conservation laws can be really helpful if you're doing big physics or fluid simulations, because those can be some of the most common sources of error, and they can also be some of the easiest to check. The simplest way to start looking for problems, though, is to add print statements everywhere for code. So basically, if you got a big code and a bunch of functions, figure out where you try to localize where the code's starting to go wrong, and then start at particularly like if you've got a set of code that is like the main code, this is what your code is doing, and then it's calling a bunch of other functions. Start by adding print statements to that main code and see at what step do you start to get the wrong answer. And then go one step deeper. Say, okay, it's maybe that say, okay, maybe it's this, maybe it's a certain function that's getting the wrong answer. Then go into that function and start putting print statements there and see what step do you get the wrong answer. So we'll look at a quick example. So for example, let's say that we have the body mass index, the BMI of a bunch of different patients. So we can have this function that says calculate BMI, weight divided by height squared. And for patients, we get the weight and height, then we calculate the BMI and for the patient's BMI. But there's a problem with this code. Can anybody see why that might be? So if I run this code, calculate BMI for these three patients, which have very different weights and heights, I will get the same BMI every single time. Specific problem in this line of code, in this code. That is why that will happen. So if I was going to start doing that, I'd have this print statement here. And I'd say, okay, well, that's going to be the wrong. I put a print statement here. I'll get it out. What we'll see is, oh, wait a minute. This is every time I go through this formula, I'm always pulling out the same patient. Always pulling out this one, and I'm never going to the other two patients. So when you print out weight and height, you'll see that every time this for loop iterates, you're always getting the same image. So because I put that text statement here, I was able to see, okay, so there's an error in this line of code. And that means that I can go and look and say, okay, I need to get rid of that index here because to change it from patients of 0 to patient. And with this for loop here, what we're doing for patient is a variable that's.
What error would you get if you run that?
What error would I get if I ran this? I shouldn't get it. I wouldn't get any error message, or I shouldn't get any.
Because height is not defined.
Height?
You do the print weight.
No, yeah.
Weight is defined because patient 0 is one element.
No, patient zero is one element. Of the
Patient is a tuple of 70 and 1.8.
Yeah,
when you only take the first element, you assign it to weight. You don't assign anything to height. So you get an undefined variable height.
No, you shouldn't. Because I into two variables by doing
But
this.
patient 0 is not a tuple. The iterator patient is tuple, but you pick the first element and then assign it.
Patience of 0.
Oh, never mind.
So
So if you would have used patient.
if I use patient of 0, that's actually a good point. If I had actually used patient of 0 instead of patience of 0, then Paul's like exactly right. I would have only had one of these values defined, and then height would have, and then because I had tried to say, okay, patient of 0 should have 2 values. Of 0, it would have only had one value. So it would have assigned weight, but not height. And then I would have gotten a name error like we had seen before, which would say, I don't know what this height is. But because I'm using patience with an S of 0, I'm actually indexing this list. It has itself as a list of 2 elements. I can pull that apart into 2 individual variables here. So this code will run and it won't create. But it will be wrong. So in order to fix that, all I need to do is change patience of 0 to actually use the correct iterator here. So what I'm going to do, what this means that patient is one of these chunks. Is every time you go through this for loop, patient is one of these chunks of 2 numbers. And so I can pull that apart into 2 individual numbers and give each other a name. BMI will change every single time, and I'll get the right answer. Example of why using print statements to debug your code is actually really important. Because print statements are really, really simple to put in, and they can show you the value of your variables at every step of your code. And in doing that, you can pretty quickly catch on to where the problem is starting to happen. And usually, and hopefully that can lead you to really quickly being able to find the actual problem in your code.
Something like, yes, the numbers for the BMIs are going to be different. But if you'll note, when you look at the calculate BMI command in the for loop, height and weight, and then when you look at the definition of the thing, it's weight and then height. So good.
Good point. So notice, so in here I made another error. So calculate BMI is defined by weight and height. So the way I have this is that weight is the first value, is the first element. Should always be the first argument to the function. Height should be the second. But I messed that up down here. So that's going to give me the wrong answer. So that's also a good reason to have the second print statement here, because it will now the numbers will be changing, but they'll still be wrong. So what I'll be seeing is these BMIs are correct, but they don't look right. So I can look at this. Oh, wait a minute. Function parameters in the wrong way. All we have to do is flip these, and then I start getting the factors.
And it says weight, height equals patient. That line okay? Wouldn't patient be an index?
No, because the way there's 2 different ways you can do for this. If you do for I in range way, if you do that for I in range, you use I as an index, then yes, you'll be getting an index. But when you loop over things like this, when you do for patient in patients, what that's doing is it's actually pointing at the actual item in the list. It's not pointing. So you can actually use this variable directly. So if I flip those 2, I'll finally get it. The easy way to do debugging is put print statements everywhere. Try to make situations where the code will fail. If you know that there's something wrong with the code, try to make situations where it will fail and fail quickly. So you're not waiting for 6 hours for the code to run and to finally run into a problem. You can do this by having small, simple test cases that your code can run really quickly on. Change one thing at a time too. So you notice how we had 2 problems here. So what you want to do is make sure one thing at a time. So with this, we noticed that there were 2 problems. Second one was that I had these parameters. It's good practice to not change both at the same time, because that could cause because in a much more complicated code, that could lead to more problems being uncovered. And you want to make sure you do it step by step, so you can the first thing you do is absolutely correct. Then move on. And always keep track of the things you've done. This is actually something that Git really helps out with, and version control, because if you change too much and then all of a sudden something else breaks, Git and version control to help you backtrack your changes. Git has the blame and bisect commands, which are really helpful for that. The blame command will help show in version control, it'll help show who made a change and when the change was made. So that can be really helpful to help for you to go back and even if you're working on your own code, you can use the get blame command to look and see, okay, when did I make this change? And you can see you can use that to sort of trace back your steps if you need to. Also, you can always ask for help. You can always ask for help. The rubber ducks is just an old jet. It's just it's sort of an old. You can go talk to somebody else who knows about the code. You can come talk to us at RCC if you need help. That can help eliminate confirmation bias. And I honestly think confirmation bias was one of the big reasons why it took me 6 hours to find that little apostrophe. It was because I was convinced my code was right. No, it couldn't be. It couldn't be that. It couldn't possibly be that. I wouldn't miss an apostrophe. 6 hours later, I missed an apostrophe. Of course. So
I missed that passing exam.
yeah, so it happens to everybody. So that's sort of the basics of debugging. Print statements are the easiest way to do that. They're the easiest place to start. And here I'll turn it over to Jose for the notebook features.
Hello, everybody. Okay, so I'll try to give you less than I gave you last time. I won't promise it. So Jupyter Notebook features, we're just gonna go over a little bit of. So we've been working on Jupyter Notebook all day, right? And there's a couple of cool things that Jupyter Notebook can help us do in addition to just running code. And you see Markdown. So Markdown is those cells that allow us to write on it, and it's great for descriptions. And also if you want to share your code with somebody else, it allows you to integrate code and text really easily. But there's also a couple other programming languages that work within Jupyter Notebooks, which are HTML and bash commands. So HTML, so for both of these codes, you put the percentage signs, you put 2 of those on top, and then the name of the language you want to use. And then Jupyter Notebook will consider that cell of that language. So we'll have no trouble reading that at all. Right? So if you have HTML experience, you can actually these markdowns look more like an HTML page, where it should be used for tables, or if you want to add media or anything else on there, right? The other language allows is R, so you can actually, if you use our studio and our programming language, you can also put it in a cell, and you can also use bash. So bash, we'll talk a bit, so there's a couple commands on bash. That you can use to install packages, for example. If you put an exclamation point at the beginning of your code line, Jupyter Notebooks will read that line as a bash command, right? We'll assume that whatever comes afterwards, but not below it, will be a bash command. So by putting the exclamation point, pip install, and then the package, you can do pip install, the one we were using today, NumPy, or pip install any of the other packages, it will install it directly into your notebook. So there's no reason to go somewhere else to install it if you're using your notebook. Again, and then you can also use any of the other back. Echo is the equivalent of print on Jupyter on Python. So echo hello world will print out hello world. And if you have a lot of fluidity with bash, which I don't, you can use it to integrate it in as well.
And just to mention bash. It is the name of the language that's used in the Linux kernel. It's the name of the Linux.
There you go. So yeah, so you can combine all these in one single notebook, and there should be no problem with Jupyter reading it through. Another, so this is just a cheat sheet for Markdown. There's a lot you can do with Markdown, as you can see, just like with all the hashtags. You can put italics, asterisks, put it in bold, drag it through if you want to just keep a version of something but not take it out. You can bullets, lists, line breaks, write Python code without it actually being code, right? So you can make the 3 asterisks Python and then just you write code, and then we'll format it like it is a code block, but it won't actually run that code at all. Tables, YouTube videos, anything. So that's actually pretty. And then if you're familiar with LaTeX for math symbols, you can also put those in there by using $2 signs at the beginning and $2 signs at the end. Okay. So if you're doing a lot of mathematical stuff, it's really useful to document the actual equations you're using before you run it. So that's a cheat sheet there. And then other components aside from the text and the code is the code and the output. As we saw, Jupyter puts the code, the output right below it, which is great. But sometimes when you export, you want to be able to allow you to have inline plots. So if I'm running this code, which is basically just making an XY plot that we're all familiar with. So it will actually input the plot right below. So you can assign code and plot really easily on Jupyter Notebooks. In addition, it allows you to do live interactions with code, so it allows you to edit easier than you would be able to in other platforms, right? Because you don't need to run all your code at one time. You can just run it by blocks, which is one of the functionalities we use today. By having blocks in Jupyter Notebook, you can actually run one, which is really useful for imports. If you want to have, sometimes for some projects, you'll end up importing 15, 20 packages. And it's better to import all of those in one cell and then move with the rest of your code. Okay, so you can work on 2 things at one time. After live interaction with code, it's documenting code samples. So in Jupyter Notebooks, we can actually have multiple versions of the same code, and you can just keep it there because we don't have to run everything at one time. We don't have to save a new file. So I can say, this is version 1 of what I did. It did not work. This is version 2. It also did not work. And when I got to version 15, it works, but they're all there. And I saw what I improved each time. So if anybody else wants to retrace my steps and do it for themselves, if you're teaching another student, or if even your professor or something wants to double check your work of how you got there, particularly if you're doing any important research, you'll be able to know where the key step was done, which is important to replicating your work at all times. Some limitations, notebooks are not self-contained. So you need libraries, and you also need Jupyter Runtime, which we equip for you today to be able to run those Jupyter Notebooks. But when you're installing it on your systems, then it takes a bit of work to do to get the numbers to work, right? And then the system state cannot be saved easily. So save me if I'm wrong, but you cannot interrupt the notebook.
I think for that though, it basically means that, you know, guys have been creating outputs all day in terms of the code. If you restart that notebook, and if it's a writable notebook, it will clear all the outputs. And so any code that you have previously run, I usually, when I'm working in Jupyter notebooks, like, will leave a comment saying like, run this code, or like, do not run this code, it will break. Because when you come back to it after you've saved it, closed it out, come back, it will.
Then the last limitation is that there's no interactive debugging or other IDI features. As we saw with Marcelina's part of the presentation, there's a lot you can do with other IDEs that are designed for making it easier for you to debug your code, and Jupyter will not do that for you ever. Even though it has a lot of pluses that we've seen. So there's a few alternatives to Jupyter notebooks. The first is Google Colab, which is a Google Drive app. So Google Colab is shareable, but it is hard to be edited by multiple users at one time. But you can actually, it's the same exact format as Jupyter notebook. So Markdown runs the same, the languages run the same when you use them, so does the Python. And you can actually share those documents to Google Drive with multiple, which is especially great because we actually used it to make this presentation because it was easy for us to move the files from one place to another. So yeah, if you ever are working in a group, more than one person editing code at one time, Google Colab is a great alternative for Jupyter notebook to use. Okay. Yeah, you can show. I think that's the end of it. Yeah, and it's just all the links that we use. But yeah, we'll show you how Google Colab works in case you ever want to use it.
Yeah, the only thing about Google Colab that's different. Does it, with the images, you have to upload those. That you don't have to embed it in the Google Colab. Embedding image links is a little different.
This is how Google Colab works. So most of the same interface, Markdown, the cells, same way. And then just adding another code block, text, moving code blocks around is a bit different, but it mostly works in about the same ways and is there on the corner. But yeah, it's really useful when it's more than one person working on the same project.
There's dark code for this one, and there's black code.
Yeah, any questions on Jupyter Notebook components, things you can use, features? And I think that's all we have for y'all today for the Python Bootcamp. Thanks so much for coming. I know it's a long day. We try to get a lot in there, but if you have any questions, you can always email us at RCC and you have our contacts and we can help you out.
Yeah, and I'll write up the support email, the email address you can contact RCC at too up here. Thanks.
And bring it up.
Any questions?
Any questions? Anything?
You guys do more Python and like on next, or you guys everything's in very.
No, right now we don't.
Yeah.
No, currently, and the reason. Subjects. I want to do more advanced subjects on topics on everything, debugging, profiling programs, advanced Python. It's just that we only have like. Sorry.
The Python Bootcamp, we have an R session next week. For those that use R.
No, bootcamp is like
Yeah, it's like an hour and a half. That's a short one.
Oh, you mean you should answer that. I think.
Yeah, it's more interesting. I'm the one giving it. So, yeah.
Yeah, if there's an interest in kind of more advanced topics, maybe I can do that. I've given actually a topic, a workshop on profiling, program profiling. All of that. And it was very good. And we have three very. So there is interest, it's just very small. Both.